before we build a decision tree with information, we first need to calculate the impact of this information that it will have on the prior probabilities, so this that we have for airports being built at location A or B. So the idea is, right, before we obtain the information, the probability of location A was 40% and B 60%. Now, we don't know what the information will tell us, but suppose it will tell us location A will be chosen for the airport. Then we have to think about, according to our information about the quality of this consulting company information, according to this, what will be the new adjusted probability? How will this 40% change up or down, or this 60% change if information predicts something? Now, this is a very analogous case to our medical test result. So what I'm going to do is I'm just going to copy the table for the medical test result. So here is this was the test for the analysis of probabilities and calculation of posterior probabilities for the test. Now, my events, right, the prior probabilities was 40%, what was actually probability for location A. So this is probability for location A for location B. Maybe I'll center this. Right, this is location A, location B, probability 40%, 60%, right? Then the conditional probabilities, as the test says, there is 70% chance that, right, if the airport is at location A, that the test would predict, right? The test is, the company is correct in 70% of past cases. So we can put here 70%, they will predict A, given that the location is A, and also 70% they predict B, given the location is B, right? And actually, because the calculations are all dependent, they are all correct, except that we just need to correct the labels. So now this is probability that the test predicts A, and this is conditional probability predicts A, and then here there will be predicts B, and predicts B. Right? So just the labels change. And what I want you to see is that by the same method that we calculated before, the information, the quality or the posterior probabilities, we now calculate what's the probability the airport will be at location A, given that the prediction of the company is A. And I want you to see, again, this time it's actually very weak information, right? Sensitivity and specificity, if you like, are only 70%. Actually, I shouldn't call them sensitivity and specificity anymore, right? These conditional probabilities are only 70%. And so this prior probability of 40% increases to only like 61%, right? And when they predict B, right, the probability that before was 60% becomes around 78% for location B, right, if they predict B. So this shift in probabilities, these adjusted posterior probabilities, are not significantly, well, not very close to 100%, 0 or 100%, but still there is a considerable adjustment, right? 60% becomes 78, 40% becomes 22, and this 40, when they predict A, 40% for A becomes 60, almost 1%, and this gets lowered to 39%. So these are the updated or posterior probabilities. And this is also important that we know what's the likelihood that their information will actually predict that information. Maybe this I should also highlight. will predict the location A, and what's the likelihood information will predict location B. And I want you to see it's 46% that they will predict A, and it's not the same as our belief that the location A will be chosen. Not like with perfect information, we assume these probabilities would be identical. Here they are not.